is called population inversion.
N2 greater than N2, number of atoms in is greater than ground.
Yes, N2 greater than N1. So N2 is nothing but number of atoms present in the excited state, and N1 is the number of atoms present in the ground state. So always N2 should be greater than N1. Then only we can have the laser action. Okay. Next one is, by achieving this population inversion, we need a pumping method. So pumping method is nothing but the process which is required to achieve the population inversion, and in that we have a different types of pumping methods. What are they?
Optical pumping,
Yes.
the collision between atoms, chemical process, direct conversion, electrical discharge.
Very good. Optical pumping is there. Electrical discharge method is there. Inelastic atom-atom collision, and then direct conversion, and finally we have a chemical process. So this will be applicable to the that is the type of different cases. Okay. Let's say about the Einstein's A and B coefficient, and we know that atoms are exposed to the light, three processes will take place. So that is called absorption, spontaneous emission, and then the stimulated emission. So here the absorption is nothing but when we are giving the external energy, the atoms present in the ground state absorb some energy and moves to the excited state. So here E1 is the ground state and E2 is the excited state. Okay, and N1 is nothing but number of atoms present in the ground state, and N2 is the number of atoms present in the excited state. Okay, so here we can calculate the rate of absorption. So first we have to calculate. So rate of absorption can be written as R12. So here 12 represents the transition from ground state to excited state. So adukkaga munda 12 represent panrom. Here this is directly proportional to this symbol is nothing but rho. Here it is nothing but a energy density. Okay, yeah? So namak energy kudukranaala we are taking the energy density concept, and then directly proportional to N1, number of atoms present in the ground state. And then in next step we have to remove this proportionality, we include one constant. Usually enna பண்ணுவோம் ஒரு constant include பண்ணுவோம். So that we have taken as a B. Either we can take A or B, and here we are choosing B for when we are giving the external energy. Okay, energy கொடுக்கிறதுக்கு B nu A க்கு என்ன பண்றோம், energy apply பண்ணாததுக்கு A அப்படினு we are choosing. So here B12. So 12 represents the absorption. Okay, so next is spontaneous emission. So here the emission takes place without giving any external energy. So automatically the atom transfer from excited state to ground state. Okay, so this can be written as R121. So to